Hi there and welcome back. In today's lesson we are going to look at the third form of a parabola, which is also known as the quadratic function. Now in our previous two lessons we learned the following form, which represented a parabola that only moved up or down, and this Q also represented our turning point. Then we introduced the function that looks like this, where we also have a term where there's an x to the power of 1. Now when we have this term that is included in the function, there was a left or right movement, and this c was our y-intercept, and we had to calculate our turning point of this parabola with two small formulas, right? Or by using the first derivative. Now today's form looks like this, where we have fx equals a in brackets x plus p, we close the bracket, squared plus q. Now when it is in this form, there's also a left or right movement, but in this form our turning point is already known, so it is given to us. This p and q represents our turning point. Okay, but pay careful attention. If this was a positive value, our x coordinate for our turning point will then have a negative number. So we basically take whatever is in this bracket, we equate it to 0 and we calculate the x. For example, if this was x plus 3, our x coordinate will then be a minus 3. Okay, so that's why I indicated it as this was x plus p, so our x coordinate will then be a minus p. So it will always have the opposite sign. This q, we use it just as it is, and that is the y coordinate of our turning point. Okay, so that is quite nice. What we need to do, however, is we have to calculate our y-intercept by making our x equal to 0. Because how do we calculate the y-intercept? We make our x-coordinate a 0, because on the y-axis our x-coordinate is always 0. Okay, and let's go and look at how we will do it in an example. Now in this example we are given fx is equal to x minus 3 in brackets squared minus 16, and we want to draw this function. Now before we start, we want to get an idea in our head of what it should look like. Now because it's in this form, we know that there was a left or right movement, and we also know what the coordinates of the turning point should be, because we are given that p and that q, right? Now we also know that a, even though we don't see it, is there, and it's a positive 1. So that means the legs are pointing up. So we've got a left or right movement and the legs are pointing up, but we don't have the y-intercept, nor do we have the x-intercepts. So the first thing that we will do to draw it is we are going to find the turning point. Now that's really easy. This is x minus 3, so if we take x minus 3 and we equate it to 0, then we take this minus 3 to the other side, so x is equal to 3. A quicker way is just to remember that whatever is written here, we're going to use this value with its opposite sign. So since it's a minus 3, I'm going to use a positive 3. So the turning point is 3. Okay, that's the x coordinate of the turning point. So the y coordinate is this value over here, this q. So it's a minus 16, and that is our y coordinate of our turning point. So let's go and plot the turning point. So we go to our Cartesian plane. It's a positive 3, so it's 3 to the right, and a negative 16, so it's 16 down, and we can put our dot there, and we can put in the coordinates as 3 and minus 16. Now the next step is to find the y-intercept. Now how do we find the y-intercept of any function? Well, we have to make the x a 0. Why? Because on the y-axis our x-coordinate is always 0. So since we have the x-coordinate and we can put it in as a 0, we can calculate the y. So we're going to say y is equal to, and in the place of the x we're going to put a 0. So 0 minus 3 in brackets squared minus 16. And once we calculate this on our calculator, we see that y is equal to minus 7. So we can plot that point as well. And there it is. And our coordinates is 0 and minus 7. Now, we already know that the legs will be pointing up, so it's going to go in this direction. So we're going to have two x-intercepts. So how do we calculate the x-intercepts? Well, on the x-axis, our y-coordinate is always 0. So we are going to make the y a 0 and then calculate x. So to get the x-intercept, we make the y as 0, and that is equal to x minus 3 in brackets squared minus 16. Now this is quite easy since both of them are complete squares, so we can take this minus 16 to the other side. It becomes a positive 16, and then we have x minus 3 in brackets squared. So to get rid of this square, we're going to square root both sides. So we're going to get the square root of 16 as well as the square root of x minus 3 in brackets squared. Now this square root is going to get rid of this bracket and this square, and the square root of 16 gives us a positive and negative 4, and that will now be equal to x minus 3. Now since we have a positive 4 and we take this minus 3 to the other side, becomes a plus 3, so plus 4 plus 3 is 7, and then minus 4 plus 3 gives us minus 1. So these two are our x-intercepts. So let's go plot them. So 7 is on the right side, so there we go. So it's 7 and 0, and on this side we've got minus 1 and 0. And now we can simply connect all these points, and there we go. Now the last thing is, what is the line of symmetry? Well, the line of symmetry is the line that goes through the turning point, the vertical line. So there is our line of symmetry. So what will its equation be? Well, if this turning point's x-coordinate is 3, that means it's 3 over there where it crosses the x-axis. So our vertical line has an equation of x equals 3, and this is the equation of the line of symmetry. It will always be equal to the x-coordinate of our turning point. Okay, fantastic. So please remember these three forms, and see you again next time. Bye.